Hello, I am Devin Acosta, Red Hat Certified Architect, Level 2. Welcome to the Linux Certification Virtual Summit. This training will be covering Apache, the basics. In addition, we will cover a little bit about Linux services, how to configure them, get them configured. Um, and so hopefully this course will give you more insight into taking the Red Hat Certified Engineer exam and feeling a little more comfortable with the tasks that you are going to be required to do. Apache, which is what Red Hat Enterprise Linux uses for most of all of their major distributions. We are going to talk about the Apache web server, in addition to web browsing and how the Apache web server plays into that. When we go back to the internet early years, kind of dating myself here, um, when we when the internet first kind of took flight, right? The premise was you would open up an internet browser, back then being Netscape Navigator or one of the earlier Internet Explorers web browsers, which was back then very limited, mostly just static images and text. And then as the internet progressed, we got additional functionality such as animated GIFs. Then we moved on to um, con- context style sheets, which gave the websites more diversity along with JavaScript. So as the web kind of progressed, as we'll see, more and more features were added to make the websites more interesting and more fun to look at. But when we talk about the Apache web server, right, and what's involved, for most of the people on the internet, they're used to typing a domain name, such as CNN.com or Microsoft.com or RedHat.com. But in addition to that, so they need the web browser to be able to browse the internet. They need a domain or web URL to load. And then, as we'll see here, they're going to need DNS resolution because the internet really works on this concept of IP address. And the IP addresses, were designed a long time ago, but for many people, remembering, an IP address isn't functional nor logical. And so um, we use this thing called, DNS or domain name resolution, which will take a domain name such as CNN.com, resolve it to a protocol that the internet understands, IP, and then it will send that request to the appropriate um, server. So here in this diagram behind me is an example of the basic web search traffic flow. Here we're showing that there's lots of different browsers, and we'll talk about the browser wars. Many of you are familiar with like Chrome or Firefox or Safari or Internet Explorer or Microsoft Edge browser. And so basically, you're at your computer, you're typing CNN.com, and then from there, your computer sends a DNS request to a DNS server that says, hey, I need to go to CNN.com. And then that server will respond with an internet IP address, which will then send that traffic, send back to your computer that IP address. And then your computer will go to that and your that server will receive your request for CNN.com. It will render the web page associated with that site and then send it back to your computer. So this is the basic flow that happens and what makes the internet probably for most users enjoyable, or at least what we mostly use it for is web browsing. As I mentioned, there's a lot of browsers out there, and it's almost like the Linux distributions where there's Red Hat and Debian and Ubuntu, and it just seems like every other day there's a new Linux distribution. Um, Much like that, the web browsers, for many, many, many years, right, there's always been the war between Internet Explorer and Mozilla and Firefox and Netscape, right? And every browser is trying to beat the next browser in speed and features and performance. And so a lot of you probably are using Mac and might be using Safari, or have abandoned Safari and are using Chrome. But regardless of what browser you're using, the end result here that we're going to be talking about is taking user requests to load web pages and then reversing that into serving up those requests is what we're going to be talking about today, which is Apache, which is one of the web servers that will answer for requests. So basically, your web browser is making a request to a web server to serve up the content. So much like the browser wars, there's also um, web server wars. So today, still probably the most famous web server out there is the Apache web server. As we'll talk about here shortly, Apache is actually on the decline in regards to serving up web pages, but for the very much of the beginning of the internet, Apache had overtaken Microsoft and has, been leading the race, if you will. But in recent years, Nginx has come out and is kind of the new kid on the block and is getting a lot of steam behind it, because Apache has been around for pretty much the existence of the internet, and with that it inherited a lot of old code and backwards compatibility and performance problems. And so Nginx was designed to be much quicker, take away a lot of that bloat, and just be a web server for the new generation. And then there's also a lot of other web servers. Another big common one is the Apache Tomcat, which probably runs a lot. Every company I've ever worked at uses Apache Tomcat, even if Nginx or Apache is in front of it as a load balancer, or kind of just terminating the SSL, which we'll talk about. More than likely, Apache and Nginx is front loading for Apache Tomcat behind. And then also Cherokee, which is a less known web server, but it is out there. So if we look at the history of the web servers here on this chart, this is taken from the internet. And there is an organization that does analysis all the time, capturing what percentage of the servers out in the internet are running the various web servers. And as you can see, back in August of 2000, Apache was still ahead of Microsoft, right? And as you see, going through the years, Apache was in the lead, and just really no one could keep up with them. Microsoft has for many years been trying to to win this race, but they have never succeeded in taking over Apache. And in fact, you see here around 2009 where IIS actually lost some steam. Um, and so we'll see here when we look at Netcraft, who does this analysis, looking at, from 2008 to current day, that Apache has slowly been on the decline. So now, as of September of 2015, which is now a year old, Apache had lost, it wasn't even about 50% of the internet. And as we see here in the green, where Nginx in 2008 barely existed, Nginx, at least a year ago, had about a little over 20% of the market. And that's pretty substantial that they have been able to get such a following behind them because, there's a lot of web servers out on the wild. And clearly, Nginx, from what this graph shows, is going to soon in the upcoming years surpass Apache and probably become the world's leading web server as far as serving up web pages. But in the Red Hat Certified Administrator and Engineer exam, Apache is what Red Hat has chosen for the default web server. Not to say that, in RHEL 8 or RHEL 9 that Nginx won't take its place, but as it stands right now, Apache is here, at least for the time being. And so we will teach you and talk to you about what Apache does for us and what you need to do to get it configured. So some of the basic features of Apache is, we can host a lot of different websites on a single server. And in fact, lots of web hosting providers out there on a single server could run several hundred websites from a single server, if not more. It also gives us access control at the host, so we can create password protected directories. A lot of us might be used to going to a website and it brings up a browser window asking for secure access, asking us to enter a username and password. And Apache supports different various authentication methods. It can be backed by just a plain password file. We can use LDAP, which is a direct, much like Microsoft Active Directory and others. It also has modules that you can add to detect, for different kinds of intrusion detection, people trying to, hit lots of web pages on your site that don't exist, or they're looking for, they're, assuming that maybe you have WordPress installed, and so they're going to try a WordPress attack against your server to see if that is the case. So you can add modules into Apache that will detect these kind of pattern behaviors, and you can block. In addition, which we'll be talking about, you can have an SSL or TLS certificate. These are the secure web pages that you would hope to see when you're especially entering in, your bank account information or your anything really regarding, an internet sale or, where you're entering secret information about yourself. Apache does support load balancing. I don't think that a lot of companies use it for that particular thing, but you can. And again, just touching on, what Apache does for us, it provides lots of virtual hosting and it can scale. And when we'll talk about how do we configure Apache, we will look at what that all means. So we're going to be talking about here in this course installing Apache, getting it configured, maybe setting up a few test domains, so we can test out, having one page show for one website, but a different website show for another. Um, Apache by default listens on port 80, which is, in this example, if you go to CNN.com and you just type in HTTP, which stands for Hypertext Text Protocol, um, then it will go to the non-secure port, which is 80. And then if we needed SSL support, which we'll talk about here shortly, you will install a module called mod_SSL, which will enable the SSL and TLS parameters to Apache. Under Red Hat Linux, the Apache server is called HTTPD. Usually in Linux and Red Hat specifically, the D stands for daemon, which means it runs in the background. And then HTTP, of course, being our web server. So we'll see shortly when we get into the demo that the process that we'll be looking for is called HTTPD. So talking about here what the method looks like to install Apache, we use the yum command, which is Red Hat's style for a package manager. So we basically say yum minus yes, just saying answer yes to all the questions, install HTTPD. And if we ran this command alone, it would install Apache with the default web page with a non-secure website. If we wanted to add support for SSL, we could, in addition, say, yum minus y install HTTPD, and then space mod_SSL. This will add the SSL module to Apache, which will allow us to secure our website with SSL certificates. There's a big movement with all of the Snowden, information that's been leaked over the years, and just in the internet and security being at the forefront of everyone's mind, that Google has pushed that we are looking to secure all of the websites on the entire internet in the next few years. And in fact, starting January 2017, the Chrome web browser will start to, in the URL, say non-secure website for any websites that are not secure. So we are leading the revolution to secure every website, whether it has, secret information on it or not, just for our own protection and to make it harder for snooping. Not that it can't be broken, but that we make it a lot more difficult to do so. So when we install Apache in the Red Hat world, and we had done the yum install HTTPD, the Red Hat, what I call religion or way of doing things, is all of your configuration files are stored under this etc directory, followed by the name of the program. And since we are talking about the Apache web server, also known as HTTPD under Red Hat terms, you will find its configuration files under /etc/HTTPD. And as I did a directory tree behind me, you will see that in there's a configuration directory which has the httpd.conf. There's also a conf.d directory. So the thing about any directory under Red Hat that has .d extension, so before, in the older versions of Apache, you would have this, etc httpd conf httpd.conf file, and it would just be thousands and thousands of lines. And so over the years, we've broken up that file into much more manageable chunks. And so when we start Apache, it will load this file, httpd.conf. In addition to loading it, it will go into the conf.d directory and it will load any files that end with the extension .conf. So the README file in this example behind me will not be loaded when Apache loads. That's more for you to read. But any file ending with the .conf extension will be loaded. And so we could have copied all the information in these .conf files and appended them to the main httpd.conf, and it would do the same thing when Apache loads, but we're trying to make Apache much more manageable. And so we're starting to break out the configuration into different files or sections. And so to make it easier to manage and easier to modify. And then the log files for Apache are going to be in the /var/log/name of the program. So in the example above, we are being Apache, we are going to be in all of the log files that you would look for any website that it's hosting will be in var log httpd. Now, by default, when Red Hat installs the Apache web server, there's going to be an access log, which will be for any web requests that the server gets by default if you don't modify anything. And then in addition, there's an error log where the Apache errors go. As you can see, Apache by default will rotate its log file every week. I believe in this case on Sundays. We want to rotate the logs because if you have a really busy website, that file could grow really rapidly. And then you'll see, right, we only keep the last 4 weeks, and then anything older than a month is deleted to conserve space and keep the web server going. So, as I mentioned, the main things that we'll be concentrating on, especially in the exam, you'll want to look at the etc httpd conf httpd.conf. That's where we're going to do a lot of the majority of the main configuration changes. We'll also look in the etc httpd conf.d directory and possibly be modifying some files that end in .conf. And then when Apache starts, the web root, which is what we call it in the Red Hat land, is var www.html. So when we install Apache and we start it up, it will look for the HTML files to be located on the server under var www.html. So this is where we would place our images, our additional HTML pages, our CSS files, or any files that you would need in regards to the web server. So common things that we can do with Apache, right? We can manage using one IP address. We can host several websites, hundreds of websites. We can add what I call a password protected directory, which we will show here in our example, which we could contain secret information. We can enable SSL, which is probably going to become the norm soon, so that we can make sure that our website is secure and that everything between the client's browser and the web server is encrypted, right? And that's important, especially when if you're in Phoenix and you're connecting to a server, say in England, where that information is going to take a long journey, and anyone that can read that information between Phoenix and England could possibly see your passwords, your personal information. So we want to make sure that important stuff is using SSL. And then we can even control access to directories in Apache by limiting it to a certain IP range or assert a set users. Now, when we're talking about the Apache web server, this diagram behind me is showing that a user will enter a web request. That web request then gets translated to a protocol, and Apache, as I mentioned, has undergone many years, I think about 30 maybe. Um, and so lots of versions of the HTTP protocol have been released. Then the server will get that request. It will send back a response, which then your browser will display to you the pretty websites that you're used to. Um, this is just one example of what the early HTTP 1.0 protocol supported in 1.1. As we can see, the 1.0, you could only have a single request per connection, and there was very limited support for caching. So, you know, that would slow down any website, especially if you're on dial-up. If you remember, your websites would load much, much slower. Where 1.1 released, you can have lots of different requests per connection. You can add caching, and compression, and so as we keep progressing with the protocol versions, we keep adding more and more features to make things faster and efficient. And we will now start doing a little bit of demonstration about actually installing Apache and getting to the nuts and bolts of what this is all about. All right, and now we are going to do the lab portion of my talk. We were discussing about um, what Apache was, and now we're going to actually show you how to install it, get it configured, and do a few things with it. So I've logged into my virtual instance that's running OpenStack, and we will log in and change to the root user. And for Red Hat, you will use the yum command to install packages onto the system. If you don't know what the options are, you can always just do yum without any options, and it will give you basically all of the possible parameters. If you kind of have an idea of what the package is called, but you don't know what the actual package name is called, you can do a yum search, and in our case, we could look for Apache. And then it will search all of the repositories and show you every package that has either Apache in the package name or Apache in the description. Right here is what we're going to want, the Apache HTTP server. So in Red Hat, it is considered the HTTPD, and then it's showing us that it's for the 64-bit version. Whenever you install a package, you can leave out this version, the architecture, and just do the first part. So to install Apache, we will do yum install HTTPD. And it will here show us that in order to install Apache, we needed 4 additional packages. It'll show us what architecture, the version, what repository it came from, as well as how much it will say yes. We'll import the key because all the packages are GPG encrypted. So that way, if a hacker happened to compromise some files on one of the repositories, because we're using GPG key encryption, we can tell whether the package is unmodified and trusted to be installed. So now that we've installed the Apache web server, it's not going to start it, and it's not going to enable it on boot. With RHEL 7, which is what this instance is running, and it had changed to the systemd system. So we would do system control enable HTTPD. As you can see, when I do this, it creates a link so that next time the system boots, it will automatically start Apache. But this doesn't start it right this instant, so we would do system control start HTTPD. We can also issue a system control status, and it will show us that the service is active and running. It'll tell us how long it's been up. It'll show us all of the processes that it has spawned and the last few lines that were logged to the Apache logs. So in this instance, the server name is just called server 1. When you're dealing with a web server, as you can see here, it complained about it could not fully reliably determine the server's name. So what's an important thing to keep in mind is whenever you have a web server that's serving up websites, you want to make sure that the server is configured using a fully qualified domain name. And what that means is it's a name, a host name dot some domain. So we're going to change this to be in the host name control. Set host name allows us to change the host name of the machine. So we'll just do server1.domain.com. And so now when we do host name, we will see that it's fully qualified. And that's what we will want. So technically, if we just go to this IP address, right, it will, and actually this will actually equal this, it will give you the default Apache CentOS web page. Now, whenever you see this page, it is an indication to you, and it even tells you right here on the screen what to do, that you should add some content inside the var www HTML directory. If we go into that directory, we will see here that there are no files. And so when Apache loads and sees that there's nothing in this directory, it will default to that splash page. So if we create an HTML file, right, and we just do some HTML code, and we just say, welcome to server 1, and we'll just close the HTML and we save it. Now, when we reload this page, we will get the message, welcome to server 1. In this purpose, I had set up some DNS that points demo.linuxstack.cloud to this particular OpenStack image. And so now this is going to, because we hadn't set up any virtual hosts, this particular Apache instance will only serve up one domain technically. So anything that points to this IP address, it will just serve up the content from the var www HTML directory to anything, regardless of what the host name is. Right, and so the configuration files are under etc httpd conf, and if we look in here, we'll see that it's very well documented. You can see that we're setting the root direct, right? If we happen to want, you would never change this in a Red Hat distribution because these are the acceptable defaults. But for instance, if we wanted to change the port that the web server was listening on, or we wanted to change, maybe the user that the a web server was running under. Um, Probably one of the most things that you'll always do in regards to Apache is work with a lot of the directory statements. And the directory statements are used to control different kinds of actions that you can have, permissions, if you will, that allow or deny certain things, so that some things may work in under one directory but not under others. And so we'll show here in a bit about those directory statements. But this file is pretty big, but it, again, is very well documented. And then if we come out of directory, we'll see that there's a conf.d directory. So we're getting into this concept of breaking out the configuration into many different configuration files, that when the server loads, it will load all these configuration files. And so that way it makes it easier for us to separate out segments of the code into more usable, digestible. So as you can see here in the welcome, this is the default, right? It's just setting up some aliases. And, and then here, if, this is the error document, if there's, no index or whatever. So what we can also show is, so say we have two domains that we want to set up so that this web server can maybe handle, maybe you want to host someone's blog on one domain, and you want to host maybe someone's maybe they just have a basic splash page, but you only have this one server and you want to utilize the capacity of the server. And so Apache allows us to do this. So we would create a virtual.conf directory, and then there's a parameter called name virtual host. Generally, you say *: in the port, and then we will create virtual host blocks that will all be named *80. But then in here, we'll say server name. So in this example, I created a fake domain called domain1.com. We'll tell it where the document root is. This is where, when the web server sees a request for domain1.com, this is where we tell it which directory to look for the files. And so in this case, we can create a directory called web-domain1.com. And technically, this is, all we would need. Now we could do, an error log and say that it's under, domain1.com -error log. And I think a access log, I believe, is what it is. So that way we can separate out all of the web requests for this domain into its own logs, in case we want to use them for troubleshooting or log, analytics. So we could save this. We will need to create this web directory and domain1.com. And because web doesn't exist and domain1 doesn't exist, we can use the -p option to make both the web and domain1. We can, let's see, in regards to Red Hat Enterprise, it has this security enhanced Linux enabled by default, which we'll talk about. It has, and some people love it, some people hate it, but it actually increases the security so that in case, someone does get in, it limits what they can do. So let's just reload the Apache configuration. Oops, we'll see here that it complains that something is wrong. So it's saying it doesn't like my command access log. Well, it's very possible that I have it spelled wrong, or so here we'll just look for access or logs. So there's the error log. Oh, so it's custom log. We can say common. All right, so we'll just use custom log and then say common. So we'll come back here. We'll just say, make this a custom log, and then at the end here say common. There's lots of different formats that you could use. Okay, so now it reloaded without an error. Now if we go into webdomain1.com, there's no files. So if we come back here, so we can still, let's see, is it running? And you can use netstat to tell if it's running. It's not. Let's see if it starts. So it still failed. So this time it's upset about cannot find, so name virtual has no effect. So here we can, again, if we don't know, we can go into the var log httpd and we can look at the error log. So here it says, so it's complaining that it couldn't open this directory. So what we would need to do, and again, this is my bad, we would come into here and say logs, because we would want it to go into the logs directory. All right, so now we see it's running. You don't know, you can always do that status command. So yeah, you always want to make sure that the logs go to the correct place, otherwise it won't be able to write. So we can again come back here. This should, so this gave us a splash page back. So let's see what happens. www.domain1.com. We get the splash page too. And so you're asking, well, why did demo now give me a splash page as well? Well, so what happens with Apache is the minute you enable the virtual host, or the managing so that you can host many different websites, the behavior changes a little bit from when it's not enabled. So you can see before this would have said server 1 because we were only telling Apache to manage one domain. And technically, now that we've enabled the name virtual host, there is no record telling it where linux.linuxstack.cloud would go. Now, technically, if we go to the IP address of this box, again, it would match to nothing. So, so the minute you, so you kind of want to, when you're setting up Apache, know from the beginning whether you're going to want to host one site or additional sites, because now we would need to create a virtual host for each of the other, and you would always want this to match. So your virtual host, whatever's here, is always going to be matched in here. But then what separates it is the server name. So now if we say demo.linuxstack.cloud, and we want it now to go to var www.html, again, we can give it the error. Generally we would have, our own log files for each of the domains. Just makes it easier to troubleshoot. And then here we can say demo.linuxstack.cloud. And the beauty of this is we're only using one IP address to host now these two different domains. And so if we restart HTTPD and we just check, it's still running, very good. So now if we come back here and do demo.linuxstack, we will get the welcome to server 1. So again, just remember, if you install Apache and you only plan to run one website, then you don't have to worry about creating per se a virtual host block to serve up the pages. It's only when you start to host many different sites that it will become an issue and that you'll need to add it. So, and just to reiterate one more time, I also created, and it doesn't matter in what order you put these blocks. So we're going to say, again, match. And again, I created one called domain2.com. Again, I just fudged my server so that these domains exist in my lab here. But again, we can look at domain2.com and give it an error log. And then we can say custom logs domain2.com-access log.common. And now if we save this, we could technically just reload, check on the status. It looks good. Now, the question you'd ask yourself is, what should come up? Well, let's just see. So if we go to domain2.com, we get a blank page. But what also we didn't do is we didn't create a directory called domain2.com. So now if we come to domain2.com and we create an index.html, which is the default, we could say welcome to domain2.com. Save it. So now if we let's see. Well, you should say, well, why did this not work? www. So let's go back to my config and take a look. www.domain2.com web domain2.com. Okay. Let's see if it created our logs. Okay, so we do have domain2.com access log. Okay. Let's just check. You can check this audit log because SE Linux may be, but for the so here it was trying to write to a directory. So let's just for fun, we'll just do that. I don't think that should matter, but okay, why the domain? Let's see. So if we come back to domain1.com, it should work. So something completely broke here because now domain1 doesn't work. So let's take a look here. Good troubleshooting. So we have server name. So virtual host, server name domain1, server name www, domain2, web domain2.com. Let me see, maybe we just that's interesting. So now we're getting, so the only one that's working is, let's take a look at if there's anything in the, no, that looks okay. Domain1 error log. So here we see that we're getting an off-core issue. Um, so because the Apache web server is running under the Apache user, let's see here. So let's just say, oh, we didn't have welcome to domain1.com, so that's there now. And let's talk about domain 2. Okay, so that should say welcome to domain 2. Okay. Why is it doing this? So it could be, let me just check. So I think I know what it is. So the Apache and RHEL 7 has changed a little bit as far as the things that it requires, but what we're going to also need to look at is a directory. So let's see, required all, so the document root. So I think it should be allowed. So typically, when we look at, if we use the capital Z option, we'll see that there's a security context here called HTTP sys content T, which is the correct SE Linux context for a web server. So we'll change context, type this to web. It was probably not that in the beginning. If we look here, see, it was just default T, so we'll change the context to here, and we can even do this recursively. Let's just see if that sufficed. So we're still not getting, okay. So what we it's not going to matter, but generally you're going to want these owned by Apache, just to be more, because unless you're logging in as root, which many cases you're not, you'll want that to be owned, but that isn't, I believe, what's stopping it, but we'll just change it. Again, I don't expect this will be the problem. So we'll need to go back and troubleshoot. So if we take a look here at the domain1.com error log. So here we're seeing it's being denied. So, right, these are new codes for Apache 2.4. So we could always go into your trusty browser and say, hey, Apache's complaining about this. Here we can see there's quite a few people talking about it. So probably what we need, so here's someone given an example. Generally, you have to go down. So we're going to say, so it's probably saying that we need to require all granted for the directory structure. So what we could do is inside, because typically this would be on a per domain basis, right? So we can actually do directory statements inside of here. And so we can say directory web domain1.com, right? And we're going to say require all granted. And then what we would need to do is copy this and put this into domain 2. But of course, we'll need to make this one say domain 2. So then we will restart Apache. We will then come back here. Welcome to domain 1. Welcome to domain 2. So as you can see, And this was actually a good learning for you, right? Once you start to add multiple domains to a single web server, it requires quite a little bit of additional configuration in order to um, make that all work perfectly. Because basically, when you didn't, and you only had the one directory or the one server serving up, these directory statements here, and basically see here there was one for www and there's even one for www HTML that is setting the required all granted. So before we were following under this directory statement, but when we go into virtual hosts, you will need to do directory statements inside of each of the virtual hosts. And so that is that. So another thing too that you, depending upon what you have your web server doing, is I had mentioned that there was this concept of SE Linux, and in that you can do get se bool -a. It will show you all of these basic toggles that SE Linux adds an additional layer of security across the entire operating system. It targets, the most common programs. And so if we look here, you're going to see that for Apache, there's quite a bit of options. So by default, if Apache tries to make a connection, say, to another web server, it's going to be denied because we're telling it that it can't connect to the network. That doesn't mean it won't serve up web pages. It just means that if you had code and that code needed to call out to other servers, it probably will be denied. And so you will need to turn this HTTPD network connect on so that the server will be allowed. And also you can see here, if we had some web server code and we wanted it to send email, by default, it's going to be blocked. So we would need to turn on that Boolean in order to have Apache allow mail to be sent. And so you can see it's really tightening down. So that way, without all these, if the server got hacked, they can email, they can do all kinds of things. But with this enabled, it really locks down that, they can't make connections to other servers. They can't, just start talking to LDAP. So it really locks it down. And so it enhances the security of the server. And so that's important. Now, one other aspect that we're going to want to talk about in regards to services, right? So I showed you how to install Apache. We did the example of, configuring Apache with a few virtual hosts, and how going from the main server with hosting the default site versus hosting 3 different sites, how we had to change that configuration around. But then also we need to talk about, in regards to services, right? Generally, this server might be running a firewall as well. So in regards to the services in general, if you run system control without any options, it's going to show you every single service, if it's loaded, if it's active. And so if you run this command, you should see no red. Now, you have to remind yourself, if you're using a terminal where colors are turned off, then you won't obviously see the red. But my terminal, as you can see, has color enabled. And so because it's all white, everything is good. So one way to kind of check your system generally speaking, if everything is happy, just run system control with no options. And if everything is white, you're good to go. Um, and so, and in fact, if we wanted to see, we'll install a firewall so we can look at that. So again, we could do a yum search firewall because we're like, well, I don't know what it's called. In rel 7, it's called firewall D. So we're going to do yum install firewall D. We will install that. And again, it's not going to enable it or start it automatically. You're going to have to do that. System control enable firewall D and system control start firewall D. Now, this is important because if during an exam, they're going to tell you that before they grade your exam, they're going to reboot all of your instances. So if you configured something but forgot to enable it on boot, then you're going to not get credit for that because the whole purpose is to survive a reboot. Now, from rel 6 to rel 7, we've converted from IP tables to firewall D. Now, firewall D does still use the IP tables framework, but the beautiful thing about it is it's much more simple to configure. And before with IP tables, whenever you would add a rule and you would need to restart to take that rule into effect, you potentially would open up the server for a few seconds and you would expose yourself. With Firewall D, there's no restart, and so you're being secure all the time. Now, with Firewall D, there's a command called firewall command, and there's this idea of zones. And by default, it puts your main interface, NIC, E0 in many cases, into the zone public. So if we say for firewall, give me zone public, and then we can say list all. Now what we're going to see here is that, and it doesn't list it here as it, but because we only have one NIC in this server, by default, it is going to be in the public zone. We can see here, though, by default, DHCP6 client is enabled and SSH. So we have, this is of course running, right? So if we do system control status firewall D, we'll see that it's active and running, and we'll see that it started. So if we come back here and we try to load this, you can see it's gone red. You may think it finished, but it's not. It's not able to load the website because now, even though Apache is configured, the firewall is preventing the web server from getting the request. So with Firewall D, what we would need to do, because it's not in the services list, is we would want to add HTTP to be allowed in through the firewall. So we can use the trusty firewall command, zone equals public. We're going to add service HTTP. How beautiful is that? We didn't even have to tell it what port HTTP was, it knew. So if we come back here to, we now can see that HTTP is going to be allowed through the firewall. So if we come back, as you can see, it's now loading. Now, the thing that you also have to remember, this command did not save it for reboot. So whenever you add something, you can test it, and if it, is the action that you wanted, then you run it again with the word permanent, and that will make sure that next time the server reboots, again, quiz alert, that it will have the HTTP service enabled. Um, and you can add if you can use you can add different port numbers, so you don't have to add them by name. You can do what we call rich rules, and the rich rules are the example of, say we want to allow from a certain IP range to access different parts. That would fall under what we call the rich rules. um, but generally speaking, right, and many times you'll have them here, or you're going to have a rich rule. Now, again, remember that you have your man pages, um, firewall, command, right? So you can look at here, and here it's again reminding you about permanent. Um, and here, if you want to, if you had lots of different NICs, you can put them on zones, and then you can have your access list allowing from one zone to another, just like a firewall would. Um, and if you go down, I think there might be an example of where we can add some rich rules. So again, here, whenever you're, doing an exam and you might have forgot something, usually at the bottom there's always examples. So again, here, this would have sufficed. But again, this would be what you'd want to do to make it survive a reboot. And I guess that didn't show us the rich rules. Um, so we don't want that. So here's the firewall D rich language. Let's see, does that work? So here's separate rules where so here's where we talk about the rich rules. So here's an example of a rich rule, right? So if we can allow new IP version 4 and IP version 6 connections for an FTP service, right? So we would have a rule, service name, log limit, 1 minute. Here's an example that we're saying for IP version 4, if they're coming from this, they can hit the TFTP server. So let's see if we can enable this rule just to show you. So I think we could do firewall command. Let's see here. I think we need to add, so what is the complaint? Unrecognized arguments. So I think we have to do, no. So I think there's another, so let me go back here. I haven't done this a lot, as this is rather new. So, okay, so that's giving us the rule, but we want to, so let's go back to firewall command. So the options, I think we have to tell it that it's a rich rule. Permanent. Here we go. So rich rule zone. List all zones. We don't want to list them. We want to add. So add permanent. Add forward port. And for the sake of time, I will cheat. Again, I usually do all of my firewalling on a real firewall or in OpenStack. And so I don't really get crazy about having to do it on the server. But let's see here. I think I'm just missing like a special permanent add source. No. Okay, we want zone. Okay. Here we go, rich rules. So this is it. I knew I was missing. So add rich rule and then in single quotes. So we would come back here. We would put this in a single quote. I knew I was missing something simple. Um, so we would add this like this, and then we would say add rich rule equals. Ah, there we go. And I'm sure if we would have probably looked at there, we would have found rich rule as an option. I just missed it. Again, this is, good that I'm showing you how to kind of, troubleshoot or figure out what you're doing. So now if we do firewall command zone equals public, list all, we will see, aha. So now we're going to allow for every IP, HTTP, SSH, and DHCP. But for this range, we're going to allow TFTP. But if you're not coming from this range, you will not be allowed in through TFTP. So again, just my normally security wise, we don't want to allow SSH open to the world. So generally speaking, at some point we would want to make this a rich rule and remove it from the services, because if it matches here or down here, it'll still be allowed. So just because it shows up here doesn't mean it's not going to be allowed. This is just going to show if it's open to the world um, on this particular interface. And because we only have one NIC, that's going to be our public interface, even if it's not technically, it might be, internal traffic as well as public traffic, which is the case here. So that again is showing you, we showed you how to install Apache. We showed you a little bit about Firewall D. I highly recommend, if you're doing the engineer exam, really study up on Apache, on firewalls, especially Firewall D, because that is what RHEL 7 uses. There's a lot of good books out there, and hopefully this lab gave you a little bit. There's so much more that we can technically get into in regards to, Apache and setting up password protected directories and that kind of stuff. But for the sake of the recording, I just wanted to show you a few things um, and to get to know. And I hope that this was informative. Thanks for watching, and I hope you enjoyed the seminar.